much closer to the actual definition of Usernet. Then congratulations, Subhas has. Congratulations, you have won the t-shirt and the mug. And our team will contact you to get your details to send in these things. So congratulations. Let's go for the next thing.
Okay, so our next keynote speaker hitting the stage is Sid Faber. So Sid is a security expert and head of the robotics team at Canonical.
Wow. Yes, and one of the main problems, one of the drawbacks of ROS 1 is the lack of security. Then how can we make ROS more secure? So this is a very important subject that is dealt in ROS 2. And then Sid is going to tell us how can we secure a ROS 2 system. Welcome to the conference, Sid. Are you ready?
Yes, I'm ready. Can you hear me okay?
Yes, we hear it. Okay. The audience is yours. Go for it.
Okay, great. Thank you very much, and thanks for having me this morning. Security is an important topic, obviously in robotics. So I want to take you through some of the features that are built into ROS 2. Hopefully you'll find them exciting. Maybe not. Maybe you'll find them very routine, which is even better because we want security to be as transparent as possible. Just turn it on and let it go. So what we'll walk through in this presentation is how you can just simply enable communication security. We're going to take a few minutes to actually look at some of the network traffic just to demonstrate that it's secure, also to help you in the future if you want to do a little bit of troubleshooting or just do some validation to make sure things are working the way that you expect them to. We'll walk through where you can find some of the key materials, some of the encryption materials so that you know where they live on your robot. And then also, if we have time, we'll look into customizing some of these features to meet your specific needs. One thing I'd like to point out is that for this ROSject, we're using just a baseline ROS 2 Foxy install. So there's nothing special that's been installed on this. So if you install ROS 2 Foxy, you have all these features already ready for you to go. You just have to set them up and turn them on. So first of all, a few words about what security is in ROS 2. There's potentially a lot of things that have to be done to secure your robot end to end. So when I talk about ROS 2 security for this presentation, we're talking about one facet. It's a very important facet of security, which is locking down the communications that happen on the robot. We're doing two things. We'll be encrypting traffic, which means that anytime that two different nodes are communicating, all that communications will be encrypted. So nobody can intercept what's going on unless they are able to have the decryption keys. And nobody can insert bogus or make-believe messages in there. The second thing that ROS 2 security enables, the communication security enables, is authentication. So that nodes that join the ROS graph are authenticated. Not anybody can join the node. You can only join the graph. You can only join the graph if you have the proper credentials to work in. Finally, before we get started actually running some code, one other concept I think that's important is to realize that the way that the ROS encryption methods and the authentication methods work is very similar to how your browser works. So if you notice on your browser tab, I'm sure you've looked at the lock icon before, and it talks about a certificate, right? In order for you to go to the construct sim, there's a certificate, and the certificate is given to the website, and it's issued by a certificate authority. It's very similar to how we make things behave within ROS. So within ROS, we're going to issue certificates to what we call a security enclave, a security grouping of nodes. Potentially it's one node, potentially it's the entire robot, but it'll get issued to a node. And then it's issued by a certificate authority. How you set that up depends on your security needs, but the issuer may be your robot. It could be a company or anything in between, right? So, but there's an authority that says we're going to issue a certificate. So that works very similar within ROS. The other thing that we rely heavily on is the way that that certificates work in your browser is how they're going to work within ROS too. So there's an interesting site here, badssl.com, that issues bad certificates. And so if, for instance, your robot has a certificate that's expired, you're going to expect to see an error saying the certificate has expired. Right? Similarly, if you have a certificate that's maybe signed by someone that you don't trust, or it shouldn't be used on your robot, that'll generate an error as well for an untrusted certificate. And there's a number of other certificate errors. So again, the way that your typical websites work, or the way that we want your robot to work, we want it to be very similar in terms of securing both encryption and authentication within your robots. So by now, hopefully you have your own ROSDevDay up and running, and yours should be set for ROS2. If it's not, use this source, the ROS2 environment, but I believe yours are all set up for ROS2. If for some reason the ROS2 commands don't work, just go ahead and source the environment just, like we typically do. And we're going to be using just simply the ROS demo talker and listener apps. So just the standard talker that publishes something on the chatter topic, right? So I would expect you've run this many times. Maybe it's been long ago for some of you, but pretty straightforward, right? And then, for instance, if I open up another terminal session and ROS2 topic list, I'll see that there's a chatter topic is what this one's actually talking to. And then if I do ROS2 topic echo chatter, you can see this session, this is a new terminal session, but it's still, it can pick the data off the wire. It can see what's going on the robot. So this is very standard fare, right? So what we want to do first off is to enable communication security. So I'm going to stop this for a second. And then I'm going to create all the security materials. And we'll go through this a couple of times during this presentation. But first of all, let's go ahead and create a directory that'll be our Keystore that is going to be used. We'll keep all of our keys in this. And for this, we'll just be using the SROS2 demo directory. So go ahead and make that directory. And then go into that directory. And then we use the ROS2 security. And the security verb is actually provided by the SROS2 tools. So that's where that comes from. That's maintained by the ROS security working group. So any questions about how they work or anything, that's the SROS2 repo is where all that code comes from if you're interested in the source. So ROS2 security, create Keystore, demo keys. And now I'm going to create a new Keystore, and you see it tells me it does a few things here. So it creates this Keystore called demo keys. This might be the name of my robot or the name of my swarm of robots or something along those lines. And then so it creates the Keystore. We create a certificate authority key and certificate pair, create a governance file, and then sign that governance file. And again, we'll see what all that means in just a few minutes here. All right, so now I've created my Keystore. Now what I want to do is actually create my talker and my listener keys. So that's these next two lines here. I create the demo keys create a key in the demo keys for the talker, and for the listener. All right, and you can see I've created the certificate, the key that's associated with the certificate, and the permissions file. One thing to note, if you're not familiar with security and certificates and so on, understand a certificate is actually a public key, right? So it's used for public-private key encryption. The certificate is how you share the public side of the encryption key. The key is the private side. That's not intended to be shared. That should stay only on the robot. So with every certificate, you have the certificate's a public key, and the key is the private key. Share your certificate, keep your keys private. So we've done that 3 times so far, and again, we'll explain to what those all are. But first, let's just go ahead and turn security on. We do that by setting 3 environment variables. First is we have to tell ROS where our keys are located, tell ROS what the Keystore is. So you see that's the ROS security Keystore environment variable. Then we have to enable security by setting the ROS security enabled to true. And then finally, we have to set the security strategy to enforce. So let me go ahead and copy these, and we'll come back again also to what those actually mean. But let me paste that in here. And then I'll go ahead and run my talker once again here. And you'll see this command's a little bit longer. Because this one says that we're going to run it using a security enclave, which is our talker, listener talker. So I'm going to run my talker, and my security enclave is going to be at this location, which is what I created up above. Okay. So here we go. I'm publishing now, publishing my hello world topics, publishing that data on the chatter topic, just like it looked like I was doing before. If I go over to my other tab here, however, you'll notice if I do my topic list, I don't see the chatter topic on there. And similarly, if I do my topic echo, that topic doesn't exist. This separate terminal session has not been set up with the security environment variables. Security is not enabled here, so this can't see it. So you can imagine if this is actually on another robot or somewhere else on a different network or different system, it would not see any of the conversations that this robot is publishing. However, if we use this terminal session down here, let's see if we can get this one, get a listener running securely on here. All right, so this terminal session, of course, is on the same machine. So you can see it has that SROS2 demo directory, which contains all the key materials and everything I need. So all I have to do is set up my environment variables. Just cut and paste those in. There's 3 environment variables. Again, the Keystore, I want to enable security and then enforce it. And then finally, we'll run the listener. And here you see this node, because it has security enabled on it, this node is able to hear the encrypted messages, while the node without security enabled doesn't even know that they exist. Okay. So hopefully you're able to reproduce that on your own, and now you've got security running. And we'll see, again, we'll talk more about what that actually means to have security up and running. But let's take a look very briefly at what these 3 environment variables were that we set, because it may be a little bit confusing at first to figure out what we've done here, right? So three environment variables that tune the security setup on your machine. The first one is the security Keystore. Again, that's we'll dig into that a little bit more, but that's the directory that holds your security keys, all your security artifacts, so the keys and the certificates and the policies as well. Then there's the ROS security enable. This was designed into ROS2 as essentially a kill switch to turn all security features on or off. So in the middleware, the middleware is sensitive to this environment variable. And if it sees that security enable is set to anything other than true, and this is case sensitive, If it's set to anything else, then security will not be enabled, and you'll run your traditional non-encrypted, non-secured, not locked down communications on your ROS graph. However, if you set this to true, but you don't set a security strategy, if for some reason while the middleware is starting up and trying to establish communications, if it's not able to set everything up properly, if it can't find the keys, or if something's corrupted or something like that, it will start in non-secure mode. So again, a lot of this is to ease the transition into enabling security. But if you set your security strategy to enforce, then nothing in your in this session will launch unless security is completely enabled and able to run. So that's kind of a fail-safe to make sure that you don't want to run unless encryption and authentication are enabled. So that is kind of interesting, the way those sessions, those variables work together. If we, there's a few questions here. We won't take the time to go through these right now, but if you want to explore these on your own or afterwards, take a look at these, and these questions will help you kind of work through what the difference is between all these different environment variables. Okay. So if you've been able to follow along, hopefully up until this point, again, not a lot that you've had to do. All we had to do was create our keys and our key stores, and we've got encryption up and running. Now, if you're like me, you should be kind of in the show me state. So prove to me that it's encrypted. Everything looks the same, but is the network traffic actually encrypted? In order to do that, I'll be demonstrating a tool called tcpdump. I believe I already have it installed in my ROSDevDay. Oh, no, maybe not. So let me go ahead and install that. First do an apt update so that all your sources get updated, and then do apt install tcpdump. tcpdump is a standard utility for capturing network traffic, and it can print it out on the command line, print it out in a terminal session. It can also print it or save it off for analysis later on, do lots of filtering and so on. It's kind of a Swiss Army knife for looking at network traffic. There's also parallels to this Wireshark, which if you are interested at all in this, and there's a link to Wireshark here on your ROSDevDay and your Jupyter notebook. If you're interested at all in digging into network traffic, Wireshark is an outstanding open source graphical tool to dig into your traffic a lot more. So think about it as the same as tcpdump, but everything is presented for you in a nice graphical interface. We're just going to use tcpdump just to do some real basic stuff here this evening. Tell you what, I'm going to close out these sessions because I want to start out fresh again. And I'll use some new terminal windows here. So I'll start a new terminal window over here. So that way, none of my environment variables are set. Nothing's, everything's starting out fresh again. Looks like a lot of folks are following along. If this is any indication, it takes a little time for the terminal session to start up, so that's great. There we go. So I'm going to start this session just by the same command to start the talker node, except that now my environment variables are not set. And what does that mean when my environment variables aren't set? It means that I should not be encrypting anything. Okay, so run that, and then I'll start off another terminal session here. And in this one, I'm just going to run the listener node. Okay, so you see the talker and listener nodes are there because I've got new sessions. It should be unencrypted. So let's take a look and use tcpdump to look at what that traffic looks like. So back in my tcpdump session, I'm going to run this. I'll explain this command in just a second. And I see some things happening here. You see it capturing packets. So what was that command that I actually ran here? So first of all, sudo. In order to pull packets off the wire, that's a privileged operation, so you need to use sudo to do that. tcpdump is a command that we used, of course. -x gives us this nice long display. It displays the contents of a packet. And -i says that I want to capture packets off of any network interface. And then this is a filter expression. I could just leave this out and then I capture all traffic. I can write it to a file. I can do a lot of other things. But for now, what I want to do is I want to capture all the traffic on UDP port 7400. So we won't get into any of the networking. Just at this point, the important thing is that our ROS discovery traffic happens on UDP port 7400. So what I've done here is capture our ROS discovery packet, ROS discovery traffic, just to take a look at what's contained in a typical packet. So this here, as you can see, this is a pretty typical packet. We see a couple of them happening here. So we'll start out with this one here. If I look at that packet, it's a UDP packet. And this destination address, you may not recognize that. It may look a little bit different to some of you. This is actually a multicast IP address, right? So if you've heard about ROS discovery, automatically broadcast, there's no master node for ROS2. It uses broadcast discovery. That's what this is. So it is using network features to send out a broadcast packet across the entire network to see if anybody's listening on port 7400. And if they are, then it has some content in there. And if we scroll around, we'll see some of the packets. Look, this one looks pretty similar, right? This looks like that talker listener stuff that's talking about, there's my enclave. Yep. So talker listener node, this is my listener node. And it's saying that it's part of this security enclave. So I can, use other tools to dig deeper into that packet, but you kind of see what a packet looks like, what a discovery packet looks like here. So again, UDP port 7400, that's built into the spec, the communication spec that ROS is built upon. So we're good there. And that's our standard discovery traffic. And the other thing that we could see, because they're both talking here, is to look at the actual data packets. And they're going to come in on a port, also on UDP, but on a port that's not 7400. That usually runs a little bit above that. And so we'll take a look at these packets, just capture a few of them here. And if you'll notice, one thing that's kind of interesting here, or scrolling up through this a bit to find here's an interesting packet here. Right? And this is interesting because this is the actual data that's going from the talker to the listener. And if you can see, there's the actual content itself, a hello world 240. Right? So that was this message that was being published back here. Hello world 240. We saw the actual content of that going on the wire. That may be a concern. It may not be, but depending on your setup, you may want to enable security for that. So let's take a look at what the traffic actually looks like when I do enable encryption. So I'm going to just simply stop these talker and listener for a second. Stop these. And then this is my listener. So in my listener, I'm going to enable security by setting the 3 environment variables, and then go ahead and run that again. So the listener is up and running. And then I'm going to start my talker. Fire that up. And now they're talking. You can see they're working back and forth. And let's take a look at tcpdump and see if anything's changed here. So first, looking at the discovery traffic, if you notice here, this looks different, right? The biggest thing that you'll notice here is that a lot of our discovery traffic is much larger, right? So, so this discovery, this will look fairly similar up until this point, right? We saw the enclave from before, but then on the bottom, I see a lot of this other stuff. This is actually the certificate. This is the encryption certificate that's included in the packet. So as it's trying to discover other nodes, it's sending out the encryption information that's going to be needed by a recipient to do that, to set up communications. If I look at the actual traffic itself, and if you dig into this in more detail, you know, you could continue to see more and more kind of features of this. There's nowhere in here will you see the actual content back and forth. So that's this message, this hello world message that's being sent back and forth between the talker and the listener. You won't find that anywhere in here because it is all encrypted. Okay. One thing you'll notice is these packets are a little bit bigger. Obviously, the discovery packets that contain certificates and so on are a good deal larger, a couple hundred bytes larger. The encrypted packets are a bit larger as well. So if bandwidth is a concern, then we have to figure out how we're going to tune this to make sure that it works optimally for your instance. And that's where we talk about that a little bit later on in this Jupyter notebook. So, all right, so we've taken a quick look at some of the packets. There's a lot more that we could do with that. If you're interested in that, I'd encourage you to start exploring Wireshark. Wireshark is really an outstanding tool for looking at our network data. But that's how you can tell the ground truth that, hey, my data is not actually being sent on the wire. It is encrypted as it goes back and forth. So now I'm going to take a look. One other thing I want to do is take a look at what we actually did when we created our Keystore. So I kind of hand waved through a couple of commands early on to create our Keystore. So let's take a look. You should have your directory, if you're following along, the SROS2 demo directory that holds all of our key materials, right? So if I go into that directory, in there, you'll see the demo key. So this is, this is one set of keys, one set of encryption material that's used for, in our case, for a talker listener. This might be for your robot or for your robot swarm. If you have a swarm of robots that you want them to securely talk back and forth and potentially only allow things into the swarm when you've got the right encryption set up, that's what this would simulate in your demo keys. Right? So if I go in there, and I look, there's 3 subdirectories here. There's a public, a private, and then an enclaves subdirectory. So let's start out with the public directory. In this public directory, we see there's 3 files, actually 1 file with the shortcut, 2 shortcuts that point to that. ca-cert.pem. This is the certificate. This is the certificate like you would see in your browser, but this is a certificate of the authority. This is the root of authority. This is the root of trust. So, and being that a certificate, it has a private key. I'll show you where that's at in a second. That's obviously in the private directory. But that's what establishes trust in your entire robot system, in this entire ROS graph, everything that's communicated, all that trust gets established through this certificate. So this certificate can be freely copied to anything in your robot system. It can be copied if you want to anything anywhere, but anyone in your robot system, in your ROS graph, is going to need to have access to this certificate because it is the kind of source of trust. Now you'll see there's 2 shortcuts here, identity CA and permission CA. As you may be aware, ROS depends on DDS, the DDS communication standard, and DDS specifies that you can separate out the idea of identity versus permissions. Identity being who is in your ROS graph, who is participating in it, whether you want somebody to participate. Permissions is what they're allowed to do when they participate. So you can separate out those tasks and assign them different certificate authorities and different trust chains completely separate if you want. By default in ROS, we put those all together. We don't typically separate those out or see a need to separate those out. So these two CAs are just linked to the root. And if you want to, there's the command for OpenSSL. We can use OpenSSL to actually take a look at what's in the certificate. If you're interested there, you'll see these are the defaults that are set up by the SROS2 utilities. Probably the most important thing you'll see is our default issuer is SROS2 test CA. Right? There's a public key in there as well as signature and so on. So another probably important thing to note is that this, like all certificates, it has an expiration date. In this case, by default, we create our certificate authorities and all certificates last for 10 years. So that's something to just keep in mind. You wouldn't want your keys to expire without you knowing it. So let's take a quick look at the private directory. And here we have a private key. So this is the private key that's associated with the identity and permission certificate authority, right? So again, there's an OpenSSL command that you can use to examine this key if you're interested in it. If you just want to take a look at it. And one thing that you should notice too is everybody that's following along should have a different key. So that means that if you try to take your key materials and use them on my robot, they won't work. Okay, they will not be able to communicate. You won't be able to join my ROS graph. You won't be able to see anything that my nodes are talking about. So this has a public key on it. If you take a look at the signature matches the public key that is in that certificate. Like I mentioned, this is the private key that's associated with that public key, that public certificate. This is your most important file. This is the root of all trust. So this is the key that you want to protect. You only need access to this key when you're creating new policies or adding new nodes to your robot. It doesn't have to be done on the robot. You can do it in another machine as long as the key and the policy files are available and all. So this is what you want to protect more than anything else. You also don't want to lose it, because if you lose it, you cannot add a new node. You cannot change your permissions. So that is the root of all trust for all things security that we do in our robot. Let's go up a little bit and take a look at a few more things here. Look at the Enclaves directory. In the root of the Enclaves directory, you'll see there's a governance.xml file. If I just take a look at that. This is in being where it's located. It's governance. This governs the entire, the security policy, communication security policy for the entire robot. All right, so it specifies what the domain ID is for the robot. So if you do use a different domain ID, when you generate the certificate, it'll get filled in. But if you change your domain ID along the way, these certificates will not work. The certificates are keyed these files are keyed to a specific domain. And then there's some default policies. Do I allow unauthenticated permissions? Do I allow do I require access controls for someone to join the ROS graph? When do I encrypt? What's my default protection for topics? Do I, am I allowed to discover topics by default, or am I protected for all that? So all these kind of robot-wide, your ROS graph-wide policies are set in your governance file. And then there's another file that we saw here, that's governance.p7s, that's an SMIME file. So it's a signed version of that same governance XML file. So just because I have the governance doesn't mean that it's the right governance file. So what we do is we sign it, create an SMIME signed file that takes the governance file, all this XML, and creates a signature for it. And the signature is signed by our permission CA. The permission certificate will you use the key to create it, and you validate it with the certificate. And then that says, hey, yeah, this policy was created by somebody that's allowed to create such a policy. So I can use this command to validate what the policy is. And you see OpenSSL is kind enough to say, yep, it validates. Okay. If I dig into my security enclaves, you'll notice there's a talker listener enclave. If we look at just the listener node and the files in there, this is where it all comes together. So all those files that we showed are actually linked. The important ones are linked into this directory. This directory, this security enclave must contain 6 files. It must contain the governance that governs how the graph works all together, the identity certificate authority and the permission certificate authority, which are actually both the same thing. In our case, we create shortcuts, create links to them. Or you could put the files themselves here, just a copy of them. There's the, also there's a permissions file. The only one that's required is a signed permissions file. That's the permissions for this particular security enclave, this particular node. Then there's a certificate for this node, which this node will share to others that it wants to communicate with. And there's a key just for this node to encrypt communications within this node, this security enclave. And so these work very similar. And if we take a look at the permissions file.
See, 5 minutes.
Yep. You'll see there's a certificate here, and the policies are similar again to, but there's very node-specific policies. This syntax looks a little bit perhaps complex at first, but there's some ways to unravel it. A lot of this is related just directly to the DDS security policy. So, and again, we can validate this signature on this document. Now, if you're not familiar with security signatures, if I make any change in this policy, if I just insert a space anywhere up here in this policy or delete a character or anything like that, then that will make this signature invalid and the robot will not launch. You won't be able to launch this node securely. And if security is not enforced, it'll launch insecure. If security is being enforced, then it'll throw an error. So hopefully this kind of walked you through a lot of stuff to get started. There's some more in this ROSDevDay. So if you're interested in security, I encourage you to take a look through this. There's a little bit of an explanation on what a security enclave is. In particular, that's grouping all your nodes together that can share the same security policies. Sometimes you have very specific policies, who wants to see what and so on. So there's some design documents on that and some more explanation on what the security enclaves are. There's also a section here, which we won't go through right now. But if you want to customize this, and this walks through actually locking down your talker node and your listener node so that they can only talk on the chatter topic, and you can't remap them to an invalid topic. So you can think of a use case where you'd want to make sure that you fire up a node, but it can only publish on a certain topic, and you can't publish on another topic. Here's a sample security policy that'll let you enforce that. So the last thing that I want to leave you with is that this is all documented in a pull request right now for the ROS2 documentation. So you should see this all being added into the ROS security tutorials. And through the ROS Security Working Group, we'll continue to improve the documentation on security. So I'd encourage you, if you have a few minutes, I could use comments on that. If you find anything in the ROSject that you have questions on, feel free to drop comments in this pull request as well as anywhere else. And certainly feel free to reach out to the ROS Security Working Group. We're always working to try to make security easy and enable some more features for security in ROS2. So I think with that, I'm going to stop there and let's hold for questions.
Excellent, Sid. Thank you very much for your presentation.
Thank you.
Very good. And Sid, can you stop sharing your screen so we can see you and ask you some questions? In the meantime, people, you know that you can put some questions on the questions tab here on the conference panel, and go there, put your questions, and also you can vote the questions that are there. And I will be asking those questions to Sid for him to answer. Okay, Sid, and let me go with the first question that has been asked in several ways, in different ways. So maybe it was not very clear on the presentation, and the people are very, very interested on that. And the question is, how can I do a ROS2 topic echo or ROS2 topic list to access all the encrypted messages?
So great question, right? How do I debug something that's encrypted? Well, as you're developing robots, you can understand why you want to do that. Understand that is your production robot. Do you want to enable that? These all are part of your security policy. If you choose with your security policy that you want to allow debugging, you have to understand a little bit about how that happens. But it's easy enough to craft a security policy that enables that, right? So typically when you debug a robot, it adds a new node into your ROS graph, right? So all you have to do is add that node into your security policy, right? So forgive me for not going into the details.
Yeah, sure.
There's a little bit of syntax. But essentially, you just craft a policy. Our default policies by now do not have that. That's probably worthy of creating an issue in the SROS2 repository. Say, hey, we should be able to create some templates for how do you create, to enable RVIS, to enable your standard debugging. So topic echo just creates another node. We just have to enable that in our security policy.
Okay, and then in that case, they are able to see the topics and do an echo and see the content and so on. Okay, that requires this extra step. And then if I have understood, then when you are in production, so your product is outside there, then you don't have this debugging node, and then the topics, they are hidden, then the ones that are encrypted.
Yes. So, and understand this depends very heavily on what is your security plan. So it's real easy to just simply turn it on. But if you turn it on without a plan, you're going to run into issues, right? So have a plan that says, okay, I'm going to allow debugging in the field, or I am going to allow just this configuration of debugging, or I'm going to drop a new policy on or dynamically generate a policy on a robot in the field to enable debugging. So whatever your security plan is, you use that key, you create a policy file, and you can get yourself up and running that way.
Okay, makes perfect sense. Then, so another question very voted is from Pablo Puente. He says, is there support to store the keys and the certificates in a hardware protected security module like TMP or HSM?
Yeah, so excellent question. And as a matter of fact, you're on the cutting edge here. So join us in the security working group if you can. We're in this conversations right now. We just had that in our last security working group meeting, and that was one of the comments, one of the things that we're working on. What we intend to do, you'll see a design document update. What we intend to do is enable PKCS URIs. So for those of you that are familiar with security, you'll know that PKCS essentially hooks the operating system API to allow the operating system to manage the key materials. Our first goal with that is to make sure that those key files, remember the very, the protected key files, the things that enable trust and enable encryption, we want those to be left in hardware if you have the option. What does that mean for you if you're not familiar? Or what that means is that imagine a scenario where you have a USB, like a YubiKey or a smart card or something like that. You can plug the smart card into the robot, and then the robot is on the graph. You pull the smart card out, and the robot's dead. Or you put the smart card in the robot, generate the key materials, and roll the robot, remove the smart card, and then the robot functions, right? So that's all what we're enabling with PKCS. It does not exist today. It is something that we're actively working on.
Okay. So that was an invitation for Pablo Puente to join your security
group.
Okay. So Pablo, you are invited to join there. Okay, yes. Great. And let me see here. Subhas Das is asking about a way to enable security for a group of nodes. I think that you already explained about the whole robot, or for a group of nodes. Is it possible, just the security for just a group?
Yeah, so absolutely, and that's one of our use cases that we've discussed a bit in the security working group, and there's some real interesting projects on that. There are a few of the participants that are interested in robot swarms, either a swarm of drones or a fleet of robots or whatnot, and we talked about the certificate authority, and the CA is the root of all trust. As long as all of your robots in the swarm use the same certificate authority, they can all be configured to trust each other. Now, again, there's a security plan, how you actually plan that and what they're allowed to do. You have to set that up. But some of the things that we're exploring right now are, for instance, like if you have a base station, and the base station is allowed to enroll other robots in your swarm. That's one of the things, or some sort of a peer-to-peer infrastructure where you can enroll other robots. Another very important thing that we're looking into is, what if you have a fleet of robots and one of them goes missing? How do you unenroll that robot? How do you revoke their certificate materials, right? And the protocols support it, or we need to run the use cases through to make sure the middleware actually supports it like we want. And thankfully, we have the middleware vendors participating in the security working group and helping us along with that.
Wow. So in my case, I have very little knowledge about the ROS security systems, and all the things that you are explaining is changing the conception of ROS into, and it's expanding the world of ROS into very another world. I think that this is a sign of maturity of ROS, and it's good. It's good.
Yeah. So absolutely, and I think my hope is that we can run ROS on an untrusted network, right? I don't want ROS to have to sit behind a firewall off in a corner, a logical corner of your network where nothing else is there. I want to be able to run it in the coffee shop on the same network that your point of sale terminals are on, because it's delivering your coffee to your customers, right? In order to do that, we do have to lock it down the same way we lock down our point of sale terminals. So the ROS encryption does that, and we need to explore those use cases. They need to mature, but I think we're getting there.
Great. And so let me ask you another question that has not been voted, but I found it interesting. It's by Robin Tomar, and he's asking if a ROS2 system can suffer a DOS attack of.
Yeah, so certainly can a ROS system suffer a denial of service attack?
Yes.
And certainly anything can in many different ways. And that's just a fact of being a network connected machine. There are ways to mitigate against that. In some cases, you can put some operating system mitigations in place, and secure, Ubuntu or whatever OS you're running on. You can simply flood the ROS graph with garbage, right? So if you just have too much garbage or even legitimate traffic, you're going to have a denial of service. So that deserves its own kind of mitigation plan, its own security plan on how to deal with that. And I think there's just simply a lot of facets to it. There's also a lot of commercial products out there that deal with denial of service attacks and different features.
Okay, so we have to stop here because of the lack of time. You can contact Sid later if you want to ask him more questions. You have his contact details. And then let me tell you, Sid, that I was inspired by your speech, and I think that is the next subject that I'm going to study on ROS2 is going to be about this, about security, because it's very fascinating, and I think that, I was inspired by your presentation, so thank you very much.
Yeah, that's great to hear. Thank you very much. And I'd encourage you and anyone to participate in the ROS Security Working Group. That's where we put it all together. Sometimes security can seem mundane, but I think you can see what all the things it enables for us, which is what we want to see.
Awesome. Thank you.
Thank you.